In lesson 5.5, we're going to be talking about parallel and perpendicular lines. Before we even go into the notes, I just want to take a little bit of time to talk to you about parallel lines, and then when we get to the perpendicular line examples, I'm going to do the same thing. You can write this down in your notebook if you want, or you can just kind of think about it and look at it with me, and then once we start the notes, take the notes. It's up to you. But here I have a set of parallel lines. So I've got this line going right here in red and then the line in green. And what you need to be aware of is if we're thinking about slope-intercept form, y equals mx plus b, just hit pause for a minute and just stop and look at that and think about what relationship these two lines have that might help you in a y equals mx plus b form. So go ahead and hit pause, just look at that for a minute, hit play when you're ready. Hopefully what you noticed as you looked at this is when you're looking at your B, they cross at two different points on your y-intercept. So they have different B's. Okay, and what you might also have noticed is that they have the same slope. It goes up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. So they have the same slope, which is your M. Really important, this is the rule that makes parallel lines parallel right here. They're always going to have a different B, and the reason they're always going to have a different B is because if you think about it, when you write a linear equation, you have an M and a B. X and Y are your variables. If I have the same M and the same B, I have the same exact line twice. So that's not parallel, that's the same line. So you always need a different B and then a same slope. And the reason you need that same slope is because if you think about it, as soon as one of these goes off just a little bit by slope, then eventually they're going to cross somewhere. So if I had a really steep slope going through here, they're going to cross right there or right there. You need something that's going to keep going at the same pattern, either positive or negative, and it's never going to cross. That's what makes it parallel. So memorize that, and you probably, we're going to write it down in our notes, but if you want to draw this picture first, you can, because that's the key right here to parallel lines. The other key to parallel lines is that in order to compare your y-intercept and your slope, you always have to have slope-intercept form, which is what we're going to talk about. Write example 1 down, and once you're ready to go through it and write some more stuff down, hit play. So when we're looking at example 1, I kind of already gave you a clue as to what you need to do just by showing you that first introduction to it. In order to be able to compare if two lines are parallel, you need to be able to look at their M and their B. So you must have y equals mx plus b form, and you look at each equation. This equation is in y equals mx plus b form, so you're ready to compare that. Hopefully everyone knows exactly what their M is and their B. This equation is in standard form. You're going to have to convert it from standard form to slope-intercept form to be able to compare it. So we're going to convert 2x plus 6y equals 12, and we're going to isolate y, slope-intercept form. And if you want to do it on your own and then hit play, you can, or you can just follow along with me. So first we're going to subtract 2x from both sides of the equation. We end up with 6y equals a negative 2x plus 12. I always write mx plus b form. Then I'm going to divide every term by 6. Or if you wanted to look at it as this whole side by 6, but you'd eventually have to split it up anyway. I end up with y equals negative 1/3 x plus 2. And the way I got that, 2 goes into 2 once, 2 goes into 6 3 times. So I simplified that fraction. 6 goes into 12 twice. Remember, when it becomes an integer is when your denominator is smaller. Here, you need to keep that 1 there in your numerator. Okay, so now you have two equations. You have this equation. You also have your original equation. which was y equals negative 1/3 x plus 5. So these are your two equations you're comparing. And you're asking yourself these questions. Do they have the same slope? So look at your m, and yes, they do. It's exactly the same, negative 1/3. And do they have different y-intercepts? You have a 5 and you have a 2. Yes. If the answer to both of these is yes, then the lines are parallel. And hopefully you can tell me why, because they have the same slope, different y-intercept. And again, if they had the same slope and the same y-intercept, then you'd just say that's the same line. It would be the exact same thing twice. But if you have different slopes, they are not parallel right away. So the lines are parallel because they have the same slope and again, that's the key to it. And different y-intercept. Now I want you to go ahead and try that in a problem just like that example. So you're going to compare these two given lines, hit pause, compare them, tell me yes or no, and tell me why, and then hit play when you're ready to check it. So hopefully you notice this is already in slope-intercept form. M equals 3/4, B equals -7. You need to convert this to slope-intercept form to be able to compare that. So first thing you're going to do is add 6x to both sides. You end up with 8y equals a 6x minus 24, subtracting 24. Divide every term by 8. And you have y equals, remember, simplify that. So 2 goes into 6 3 times, 2 goes into 8 4 times, x, subtracting 8 goes into 24 3 times. So now this equation, we have m equals 3/4 and b equals -3. So again, you're going to ask yourself these questions. Do they have the same slope? Yes. Do they have a different y-intercept? Yes. So they are parallel. And again, you would answer that because they have the same slope and a different y-intercept. I'm not going to write it there because I ran out of room. Go ahead and add this to the left side of your notes. It's just reviewing how we got to these examples. So in order to be able to compare to see if lines are parallel, you always need them in y equals mx plus b form, slope-intercept form. That's what I said right there. Your equation should have the same slope and a different y-intercept to be parallel. Otherwise, you just say no, they aren't parallel. Now we're going to move on to the other thing that you need to be able to look at with parallel lines, which is writing an equation of parallel lines. This is going to tie directly into lesson 5.4. So you have to be really good at writing equations. If you're really good at writing equations already, sorry, then this is going to be really easy for you to pick up on. If you're still having a little trouble with that, just really focus on the format that you learn for writing equations as you're doing this, because it's going to help you improve that at the same time. So hit pause and copy this down and hit play when you're ready. So when you're looking at this, your main focus needs to be that you know that parallel lines have the same slope. So again, parallel lines have same slope. And because of that, all you have to do is take the line they gave you. They said your new line is going to be parallel to this line. Well, if it's parallel, I already know my m. The only thing I don't know is my b. But I have m, I have x, I have y, do exactly what we were doing when we were solving for equations in slope-intercept form. I have m, I have x, I have y. I don't care about this b, because remember, they have to have different y-intercepts, so I'm never going to use that for my new line. I want to find a line that crosses somewhere else on b, on my y-intercept, that's going to end up going through that point, but it's still going to have that slope. So you take your slope from the given line. Okay, you're going to take your slope from the given line, use m, x, and y to find the b for the new equation. It's lesson 5-4 exactly. The only difference is you have to go to a given equation to take the slope from it. Instead of them just saying write an equation with a slope of this and a point, you have to go get your slope, but you have a point. All right, so let's walk through this. M equals 3 over 5. Now, if this had not been in slope-intercept form, you would just convert it to slope-intercept form to find the m. And you do run across those, but at this point you should be able to do that with no trouble at all. And then we're given the point 5, 1. I'm going to go ahead and walk through this both ways. I'm going to walk through it using slope-intercept form because that's really what I prefer. But then I'm also going to walk through it using point-slope form for those of you who have found that you really like point-slope form. And that way you can see both ways and then you can choose which one you want to use. So we're going to go slope-intercept form first. And again, this is what I recommend, but every year I do find some students who really prefer point-slope form, so that's fine also. Y equals mx plus b. I'm plugging in mxy, finding b. So this is what I want to find. I don't care about that one. Every year there's a bunch of kids who get confused about that. So y is 1, m is 3/5, x is 5, or I'm going to put it as a 5 over 1 for those of you who prefer to see it that way with a fraction. 1 equals, my 5's cross cancel and become a 1, so I have a 3 plus b. Subtract 3 from both sides. I end up with a -2 equals b. Now you don't want to stop there, that's b, but you want the equation. So an equation that is parallel to this equation is going to have a slope of 3/5, and there's my new b. Y equals 3/5 x minus 2. And that's your parallel line that crosses through that point. So now looking at it in point-slope form, again, you still just need a point and your slope. So you're going to plug these in to your equation. So y subtracting, and then you remember you have to watch your signs. So this is just a +1, so I can just put 1 there. If it was a -1, I'd have to change that sign there. Equals my m, which is 3 over 5, and then parentheses x subtracting, and now I go check again. This is positive, so all I have to do is put a +5 there. If that had been a negative, this would actually be a negative, which would become +5. Okay, this is your answer written in point-slope form. But from here, most problems, especially multiple choice, are going to ask you to finish them in slope-intercept form. Once you've plugged it in here, now you're just going to convert to slope-intercept form. And this is if you need to. If you were taking a multiple choice test or something where it asked you to write the equation in point-slope form, you're done there. But most of the time you're going to end up having to take this step anyway. So you're going to distribute 3/5 to each of these. You end up with y minus 1 equals 3/5 x subtracting, okay, I'm doing my multiplication here, 5 and 5 become a 1, so I see that that's just 3. If you need to do that over off to the side or something, you can do that. Don't make mistakes on these. Some of you might even have just said 3 times 5 is 15, 15 divided by 5 is 3, and brought your negative. That's fine also. Okay, now you're just going to isolate y by adding 1 to both sides. And you end up with y equals 3/5 x subtracting 2. Same exact equation both times because you were finding the same equation. You just used a different way to get there. Go ahead on the left and just add, because this one we were doing in slope-intercept form. So here you can say, or use the point slope form, then isolate y, or convert to slope-intercept form. So you're going to do one of those two things. Now we're going to move on to perpendicular lines, and these are a little bit harder to see the original change in a perpendicular line, but hopefully once we go through it you'll kind of see the pattern. If you understand how to set up and write equations and find if lines are parallel, then you just have to memorize the rule for perpendicular, otherwise you're doing almost exactly the same thing. So if you notice, parallel lines never crossed. Then we just have regular intersecting lines. Intersecting lines cross, they just cross somewhere. And then we have these special types of intersecting lines like perpendicular lines. And in case you forgot what a perpendicular line is, a perpendicular line, wherever it crosses, crosses at a 90-degree angle right there. So these are two perpendicular lines. This perpendicular line, if you notice, just so hopefully some of you can kind of see this, this is a perpendicular line right here. If I was to move it over onto the y-intercept, it's still a perpendicular line. So one thing that I want to point out right away is that your y-intercept no longer matters. Crossing there isn't going to make it the same line. Where the parallel lines, if I happen to cross it at the same spot, well now I've got the exact same line. Perpendicular, B does not matter. Your B can be over here, your B's can be different, they can be the same, it can cross right at B, it can cross down here, so one is crossing here and one is crossing here. It doesn't matter. All that matters is that when it crosses, it's at a 90-degree angle for it to be perpendicular. And the key to crossing at a 90-degree angle, some of you might kind of see it already, but we're just going to count it out and notice. In green, let's count out our slope. In green, we go down 3, right 2. So down 3, right 2. If we look at our red slope, we end up going up 2, right 3. So take a second to look at those and compare them. What you should have noticed is that they're the opposite sign, so one is positive and one is negative. That's what gets these to turn and cross at a nice angle like that. You're always going to have one positive, one negative. The other thing a lot of you probably noticed is you have your reciprocal. 3 over 2, 2 over 3. Now every year I get students who start to think negative goes with a reciprocal. It's not. A reciprocal is not talking about opposite sign. It's only talking about flipping a fraction. Numerator becomes denominator, denominator becomes numerator. The sign is a different part of the rule here. So there's two parts to your slope changing to be a perpendicular line. It needs to be the opposite sign, and they need to be reciprocals of each other. Nothing to do with B at all. You're only memorizing something that has to do with M. So now we're going to go into perpendicular lines. Write this down. Once you're done writing it down, hit play and we'll go through the example. It's exactly what I just talked about. For two lines to be perpendicular, you're going to look at your M, your slope. You need to have the opposite sign between the two and the reciprocal of each other. It must be both to be perpendicular, not one or the other. And in order to find slope, you need to have this is in standard form. You need to have slope-intercept form. So this equation is going to need to be converted to slope-intercept form. So you have 3x plus 5y equals 7, and you subtract 3x from both sides. You end up with 5y equals negative 3x plus 7. Divide by 5, and remember you're dividing every term. So you end up with y equals negative 3/5 x plus 7/5. Now you're going to compare m's. So in blue, or in this turquoise color, we had m equals 5/3. And in our red equation here, we had m equals a negative 3/5. And you're asking yourself, do they have the opposite sign? Are they reciprocals? Yes, they are perpendicular. Because they have opposite signs and are reciprocals. Okay, so again, if it had only been 5/3 and 3/5, not perpendicular because it's not negative. If it had been 5/3 and negative 5/3, not perpendicular. Those are just lines that randomly cross. Now I want you to try it. So copy that down, hit pause, try it on your own. Remember to give me an explanation for your yes or your no. Hit play when you're ready to check. When you went to go look at these, notice they were both in y equals mx plus b form. So this one was already set up for you nice and easy. All you had to do was look at m. M equals negative 3/5, m equals 3/5. And you ask yourself the question, are they opposite signs? Yes, they are. Are they reciprocals of each other? No, they're not. So these lines are not perpendicular. So they are not perpendicular. They're basically just two lines that are going to cross somewhere at some angle. They're not perpendicular because the slope is not a reciprocal. Okay, so it was the opposite sign, but it's not a reciprocal, so they're not perpendicular. I'm going to continue calling this example 3 because the book didn't actually give you an example like I just gave you, but I wanted to walk you through that because you do come across problems that ask you it. They just kind of assumed you would apply the exact same thing to parallel, and I didn't want to assume that. So this is example 3 in the book. The example I just gave you was an extra. Once you're done copying it down, hit play, and we'll go through it. So you're going to use the exact same idea that you did with parallel lines. That's where I don't want you to overthink these. A lot of this stuff, really you apply the same rules, but with just different twists to them. So we're using the exact same idea. you have two different ways that you can write equations. Point-slope form, slope-intercept form. And like I told you, I always prefer slope-intercept form, so I'm going to show you using slope-intercept form first, but then we'll go through it point-slope form also, so you see both ways. Okay, same idea as parallel. When you were looking at parallel lines, when this is in slope-intercept form, you knew you had to have the same slope. Well, when you're looking at perpendicular lines, this needs to be in slope-intercept form. It won't always be in slope-intercept form, but you know how to convert them now. You have to find your m. So in this case, m equals 5, which means your new equation, the one that's perpendicular, is going to be the opposite sign and the reciprocal. Positive becomes negative, 5 over 1 becomes 1 over 5. So this is the m that you're going to use. All I did was take slope from the one it's perpendicular to, make it the opposite sign. It doesn't mean it's negative every time. If this was negative, that would be positive. Opposite sign, reciprocal. Now I have m, I have x, I have y, exactly what you've done every other time. You need to find b. So you're going to take m equals negative 1/5, point is 0, negative 2. First way we're going to look at it is in slope-intercept form, which remember is y equals mx plus b. So there's my y. There's my x, there's my m. I'm solving for b. So you're finding b. Negative 2 equals m, which is negative 1/5, times x, which is 0, plus b. This one was really easy because 0 times negative 1/5 is 0. So negative 2 equals b. And then I write my new equation. They asked for an equation. They didn't ask for b. And remember, equations always leave out the x and the y. So it's m and b. Y equals negative 1/5 x minus 2. And that is my equation that's perpendicular to this line and contains that point. Now let's try it using point-slope form. So we're looking at y minus y1 equals m times x minus x1. And we're filling in the y1, the x1, and the m. M is negative 1/5. Y is negative 2. Be careful when you go to plug that in there. So y minus a negative 2 equals negative 1/5 times x minus 0. And then you want to simplify all this. Y plus 2 equals a negative 1/5 x minus 0, because when I multiply 1/5 times 0, I get 0. And actually, sorry, negative times negative is positive. So even though it's not going to change it, I'm still going to keep my proper form there. So plus 0. And then I need to isolate, and I'm actually going to go ahead first and rewrite it without that 0, because we don't even need it there. Now we're going to subtract 2 from both sides. You didn't have to rewrite it without the 0. It's just I probably would never even have written this part, but I wanted you to have it in your example. And we end up with y equals negative 1/5 x subtracting 2. Same equation as you had here, because either way works. Write this into your notes. It's again exactly what we talked about. You're taking your m that you're given. New m is going to be your opposite sign and your reciprocal. And I tend to circle it so I don't accidentally use the old one later. Then you're going to use what we've already learned in slope-intercept form or point-slope form to find your new equation. And remember, you always write these as equations. example 4, you can go to page 261 in your book, but it's a map, it's a grid, and it's on a coordinate plane, and they give you a line, and on that line they give you enough spots where it crosses really nice and even that you can get 2 points from that line. And it's talking about a park, and they're going to end up putting a path that's perpendicular to a road that they already have, and they want to know where they can put this park out on the grid that's going to be perpendicular to these 2 points. And within that, I'm just going to give you the points, but if you ever want to go look at it, you can. And I'm just going to tell you that the given line has the points 4, 5 that it crosses through, and the point 2, 1. And then it asks us to find a point that's going to, or a parallel line that's going to, a perpendicular line that's going to cross through the line that has these 2 points. It also wants you to find something else that we're going to add in a minute here. So, what can you do with these 2 given points? Hopefully you figured out you can find slope. And the way that you're going to do that is that formula. We're right back to that formula again. Underline your y's. M equals 5 subtracting 1 over 4 subtracting 2. Remember, if I use 5 first, I have to use 4 first. Equals 4 over 2, which equals 2. So my slope is 2, but that's of the line that's given. Now I need my new m. And because it's perpendicular, opposite sign reciprocal. If it had been parallel, that would be my m. But I'm looking for perpendicular. Opposite sign is a negative, reciprocal is 1/2. So my new equation has an m of 1/2, or negative 1/2. Now, if you were to read into this application problem further, they actually give you the y-intercept on the graph of where they want the line to go. So they already told you, by the way, it's going to cross on my y-intercept at 4. I didn't give that to you before because I just wanted you to focus on finding slope. Hopefully most of you already noticed now I've got m and I've got b. You have a linear equation. So all you have to do is write it y equals negative 1/2 x plus 4. This is the equation of the road that would be perpendicular to the road they gave you in the map. And again, if you want to go look at that more specifically in application, it's on page 261. I just wanted you to kind of see the process because you're going to get a chance to do a couple application ones when we work on it, of finding slope with 2 points, being able to flip it around to the opposite sign in the reciprocal, and then also using given info. Now there might be other times where they give you 2 points and then they just say, and the new line is going to cross through another point. Then you would use your new m, your x, your y, find your b. So you can always go back to that if you understand that concept. And that is the end of lesson 5.5.